Hi everyone. I think we'll get started because we've got a packed agenda for you today, so we want to make sure we stick to a good time. Welcome to the Beyond Peering series. It's the next event in the AFPIF virtual peering series. My name's Lynsey and I work for the marketing team at the London Internet Exchange, or LINX as we're referred to. So I'll be introducing the event today. Firstly, we're going to say thank you to all the event sponsors. Thanks to Darwin, Carolyn from DKIX. Thanks to Petra from AMSIX, Ben and Andrew from Facebook. And also the team here at LINX are really pleased to be supporting the AFPIF event once again. So thank you everyone, thanks for your support. We also have a series sponsor, so thank you to NAP Africa, Andrew, Carla, Michelle. Thank you everyone. They're sponsoring all four. And also, thank you to our simultaneous interpretation sponsor. So that's Fergus, Renee, Marcus, Portia. Thanks everyone. So they'll be providing or supporting the interpretation service throughout the whole of the four events in this series. So how to get involved today. We want you to get the most out of this session. So there is an interpretation support service at the bottom of your Zoom bar. You can choose to switch between English and French in that function. So have a go and make use of that to make so you can understand the session to the best effect. We have a chat room function as well, so please get involved in the chat function. We want you to network, maybe share your ASN or organisation, or just say hi to everyone who's watching. Any questions for the presenters, please post them in the Q&A function, and we'll be asking these at the end of each session, at the end of each presentation session as we go. If you're on social media watching this, watching the live streams, or please use the hashtags, share that you're here. We've got hashtag #IPeeringAfrica, virtual peering, IXP, maybe beyond peering. So it would be great to share that you're getting involved. This session, as I mentioned, is being live streamed on multiple platforms, and also it's being recorded so it can be watched back after this event on demand. So after the main content today, we'll be handing back to the event organisers to run the peering personal sessions. So stay on the line if you've opted in to hear those. It will be a different organisations introducing their network, their ASN, and it's a great chance to network with other potential peering contacts. So here's what you can expect to get out of today's session. We want you to be able to learn more about good peering economics, why peering is never free, and how to develop a good peering strategy. It's the role of IXs play. What role do IXs play? Learn more about programmable telecoms and its impact on peering, how telecoms as a service has evolved and how is it driving forward new projects. Also get an insight into how IXPs are evolving their business strategy to be able to offer more than just peering. And then we'll be finishing with a demonstration of the new universal IX API solution. Why is it beneficial, and how easy it can be to use and adopt for both networks and other IXs. So here's our lineup for today. We'll be starting with Susan Forney from Hurricane Electric, moving on to Nico Walters, who's from CMC Networks, then on to Mark Daley from Epsilon, and finishing with Mike Hellers at LINX before we come back and let Mark and Mike run the IX API demonstration. My colleague Esther Cobbinah, who's a network engineer here at LINX, she'll be moderating the session, so she'll be asking the presenters the questions that you'll be dropping into the Q&A function. So look out for her after each session. And without further ado, here is our first presenter. I'll be handing over to Susan Forney, who is a network engineer at Hurricane Electric, and she'll be presenting about good peering economics. Over to you, Susan.
Hi, let me share my screen. There we go. Okay, so I'm here today to talk to you about peering economics. The topics I'm going to cover today about peering economics are why peering is never free, when peering is worth the investment, how to develop a peering strategy, and how to be a good neighbor. So the reason why peering is never free is because it actually costs money. We just don't think about how much. Peering is a connection between two network devices, and of course, network devices require money. People are needed to configure and maintain network devices. People are not free. As a matter of fact, people are probably the most important cost in any of your networks. So, and then network devices, of course, need electrical power and a space to occupy. You need a place to rack them. So power and space are not free. They charge money for those. So these are all things to consider when you're thinking about joining an internet exchange. So while peering has a cost, for any business case, you're going to have to know what the value is for that and to get that return on investment. And to determine the value, you're first, of course, going to need to know how much your port costs. Besides the cost of the actual port on your equipment, don't forget the optics, the power, the support costs for having something in a facility. How much a cross connect costs in the facility at the data center that hosts the exchange, and don't forget the setup fees. And while it's true that you would have to have most of these things if you were going to connect to an ISP in a data center, this is a good exercise. If for no other reason, it'll help you when that accounting guy comes along and asks you for your budget for next year. So to make this a little bit easier to understand, I've come up with this handy chart showing the difference in cost between an internet service provider and an internet exchange. And I've used kind of broad numbers to make the math easy. Your mileage may vary, but this is just for purposes of illustration. So for an ISP, the one-time costs for a device port are the $200 for the port. That's what I figured it costs on a piece of equipment if you're consuming a port. The setup fee for the cross connect, $500 in both places. That's the same. Setup fee for the service, I've noticed that the ISPs tend to be a little bit less than the IXs for the service. I put $250 for the setup fee for the ISP and $500 for the internet exchange. And then after, so once you get those sunk costs out of the way, you have to think about the recurring costs you're going to pay every month. So I'm assuming a 10 gigabit port and a 2 gigabit commit, which is relatively standard. And I'm going to say that commit price per month is $2,000. And then if you exceed above that megabits, or exceed above that 2 gigs, I'm going to say it's $1 megabit for easy math. Of course, we don't have a price per port here. And then we have price for the cross connect. And then over on the side for the IX, we have we don't have a commit level and a commit price and price per megabit because you're free for those nasty 95th percentile billing when you're on an internet exchange. So then we just have the price per port and the cross connect, So that's our monthly recurring costs. So then if we take all of those numbers, then we have the information that on what it's costing us, then we need to see if it makes good business sense based on cost. And if we take a look at that, I have this little graph that shows you, okay, this is graphed from 500 megabits to 8 gigs. It was just easier that way. I tried going to 10, but just made the slide long and kind of an eye chart, and it's bad enough as it is right now. So if we look at that, the ISP obviously is a lot more expensive. It starts out, relatively high comparatively to the internet exchange. And then as they both converge a little bit, the internet exchange still stays very competitive, ends up around 20 cents a megabit at 8 gigs, while, we're, attenuating toward $1 per megabit on the internet exchange or on the ISP. So we are, clearly saving money on the internet exchange if we're just looking at it on the flat rate. But it doesn't really work that way because you have to have some transit. Not even Hurricane Electric can get all of its internet connectivity from peers. So we have to have some traffic going to an ISP and some traffic going to the exchange. And for the sake of easy math, what I have done on this chart is put 50% of the traffic on the internet exchange and 50% of the traffic on the IX. So we have our original chart lines from the last chart for the ISP and for the exchange. And then that center line is the actual cost per megabit if 50% of the traffic were on both exchanges. And so it still looks pretty good. But there is one more thing you need to take into consideration when you are configuring these costs, and that is that pesky commit price. So actually, if you've got 50% of your traffic on the internet exchange and 50% on an IX, you're going to have 4 gigs of traffic before you meet that commit on your ISP. And that, commit is just money falling on the floor if you don't use it. So it's really important to keep these things in mind when you're trying to figure out whether or not joining internet exchange is a good idea. So then, in addition to our monthly recurring costs and our sunk costs, don't forget to factor in your operational support costs and save by streamlining and automating them. Because remember, I did say that people were going to be your most expensive investment in this. So create peer groups for your neighbors, so it takes people less time to configure them. You may want to automate that. Consider the support priority. You may not want to wake up your expensive engineers to reconnect a peer on an exchange if it's not very important. So you might want to do that. And then monitor your port capacity on the internet connections and increase it before you get into trouble. This is important because that port fills up faster than you know it. And so you really should be keeping an eye on it to make sure that you don't drop packets on the floor. Now, in an investment for your network, sometimes performance is just as important as money. So peering can provide tangible benefits in terms of reduced latency and improved throughput. You're going to gain more diversity at your edge, which will help you, and this will improve traffic. It will improve your traffic management and can help your routers rebuild their tables faster, more quickly when a link goes down, if not all of your traffic is in one basket. And it improves the scale of your network and prepares you for future growth. And this will result in internal and external customers being happier. So that is worth something. Now that we've talked about how much it's going to cost you and your business case, let's look at developing a peering strategy so you can get a better value out of your investment. The next thing to do is to target the exchanges that are going to have the most to offer and figure out who you would really like to peer with when you get to an exchange. So to determine if that port's a good investment, you should consider who your potential peering partners are on the exchange. Exchanges where you can reach content networks or cloud providers can be very advantageous. For example, if you are a Amazon, Microsoft, or Google customer on their clouds, and you can peer with them on an exchange, this certainly is going to make a big dent in your transit bill. Also, don't forget to peer with caching networks like Akamai, Fastly, and Limelight, because that's where a lot of your packets go first, and you can save a lot of money by peering with them. NetFlow and SFlow can give you a lot, SFlow can give you a lot of information about your traffic sources and destinations. And what I like to point out here is that it might not be what you expect. At one point, I was helping a university when I was working on the Boston Internet Exchange, try to figure out who to peer with. And they set up SFlow so that they could figure out they were thinking which research organizations might be the most advantageous. And they were thinking about places like Microsoft and Google would be great, if you're thinking about this free flow of information on a college campus. But what they discovered was 75% of their traffic was going to streaming services like Netflix and Hulu, because what they failed to factor in was that they were providing the internet service for the college dormitories. And that was where the bulk of the traffic was going and the bulk of their transit costs were. So of course, the first persons we hooked them up with were Netflix. So that saved them a lot of money. But that's just an example of how you might want to take a look where your traffic is going, even if you think you know where it's going. So armed with all this information, you should start investigating some exchanges. Now, on bgp.ag.net, we have a list of all of the peering exchanges. And so you can browse through them and see which ones are close to where you are, or it might be advantageous to join and get, at relatively close proximity, or in cases of, some cases in cases of countries or geography might be better for you. So you can take a look at them. Now, since we're doing AppPIF, I'm going to take a look at NAP Africa. And if you click on the exchange, a little page pops up and gives you information about that exchange. And it shows you all of the people that are on the exchange, as well as links to handy things that the exchange has to offer. Like, for example, North Africa has a link to their peering traffic. So you can get an idea of the kind of traffic that's going across there. And if it looks like, that would be good for you. So a quick solution at most public peering exchanges, if you just want to get your feet wet, is to peer with the Internet Exchange's route server. And this will have some advantages for you. You'll only have a couple of peering exchanges with the route server, so that cuts down on the amount of work you have to do. And it's a quicker way to access many networks on the exchange. And even if you decide you want to peer individually with people on the exchange, you can still peer with the route server, but you may want to prefer any directly connected peers over the route server routes. The disadvantage of using a route server is you do have less control, and you may not get all of the available routes because not all networks advertise all of their routes to the route server. Some advertise only a subset, so it might be advantageous to peer directly with them instead. And some networks choose not to peer with the route server at all. And then lastly, not all exchanges have route servers, although nowadays it is pretty common. So a peering strategy will help you get the most value from your exchange port, and you can evaluate these attributes first. As we mentioned before, are you reducing transit costs on that port? Can you send traffic to this peer that you otherwise would have to send on your transit connection? And are you going to get a lower latency? Again, for the example of cloud providers, in addition to saving money on your internet connection, it probably is going to improve your performance. And do you have excess bandwidth on your IX interface and on the ingress-egress interfaces on your router? And this is an important question because it can get, very exciting to start turning up a bunch of peers, and then you turn up a big one and discover that, oh, you're out of room, and that was maybe not such a good move. So always good idea to do these things in a maintenance window and make sure that you have enough capacity. So a peering strategy helps you look at the big picture as well as the small one. And I'm going to give you an example as to why you need to think carefully about your network architecture and traffic patterns. So in this diagram, I have a green network, and the green network has a satellite office, which is a little building icon in another country. And it's got a backhaul connection to that satellite office, and both the satellite office and the green company have a connection to the internet. And they like to do a lot of communication with a partner, which is the blue network. So everything's working really well. The green network has good connectivity. The satellite office has, good latency. And then the green network discovers that there's an internet exchange that would allow it to peer directly with the blue network and save a lot of money on transit costs. But what it fails to take into account is that once it prioritizes that route for everything on its network, now the satellite office in another country, instead of going through the lower latency route through the internet to the blue network, is now going all the way back to the country for the mothership, across the internet exchange, back to the blue network, and then back the long way. So that's causing a performance problem. That's the kind of thing you need to keep in mind when you do these internet exchange. When you connect with a peer on an internet exchange, you need to think about how it's going to affect your traffic pattern internally and do the thing that is best for your network. You might need to lower priority on some routes or do geographic communities to help yourself out. A lot of peers will advertise those to you to make it a little bit easier, especially ones that are located in many places. So those are all things to keep in mind. Now we're going to talk about our last topic, which is why you should be a good neighbor. And peering works when it is a good experience for both parties because it's voluntary. So first, clean up your advertisements. You should not be leaking your private IP space or routes that don't originate from a public AS across to your peers. Be easy to keep in contact with by updating your routing and contact information in PeeringDB or on your local RIR database. Keep your IRR records up to date and create RPKI ROAs for all of your prefixes. And then while the other network you are peering with is probably a fine organization, trust no one. Set maximum prefix limits for your peers. And the reason why I tell you this is a story that I have from back when I was working at Microsoft, and I had a colleague that worked at another company, and I came into the Internet Exchange hub for the city of Seattle, which is the Westin building, one morning, and he was crawling out of the elevator half dead. And I asked him what had happened. He said, "Oh, one of my peers advertised the internet to me last night." And I looked at him and said, "You didn't have maximum prefix limits set on your peers?" He said, "I do now. So don't let that happen to you. Set maximum prefix limits. Accidents happen all the time, and people do things they don't intend to. So don't be affected by it." And then while we're on that topic of not being affected, filter your routes to accept only the valid routes from your peers, again, so you don't accept things that you wish you hadn't. It's easier to create a filter for your peers than you might think. You can use a tool like BGP-Q3 to generate a prefix list. I've got an example here where I've done it for a Juniper router. I've just typed in BGP-Q3 -J for Juniper, -6 for the IPv6 list I'm creating, and L so I can give it a name. And then BGP-Q3 pops my configuration out right there with all of the prefixes that are allowed for that AS. Simple. You can even automate it. So also be responsive when you're notified of an issue. Nobody likes a network that ignores them, especially if they're experiencing a DDoS attack or one of your customers is doing something naughty that they want you to stop. No one can take advantage of you without your permission. You're the one that controls your advertisements. So, control your advertisements and make sure that your traffic is going where you want it to. And at the end of the day, not all networks are going to want to peer with you. And this is usually more of a problem with their peering policy. It's a case of it's not you, it's them and their strategies. But even if they decide not to peer with you, it's always a good idea to check back later, because sometimes people aren't peering for capacity reasons, or maybe they're moving to a different location. And if you keep contacting them, sooner or later, you might be successful. So be persistent. So the internet turned 50 on October 29th, which means it's almost 51 years old, and peering exchanges began to be formed in 1993. They haven't gone out of style. During the pandemic, 7 of them have formed this year. And the reason for that is because exchanges are the backbone of the internet, and they have been able to improve our networking in ways that transit providers just can't. Communities form around exchanges that are invaluable for you getting connections and involvement that you would not ordinarily be able to have if you didn't belong to an exchange, and get benefits that aren't available from other sources. So joining an air exchange, has will do a lot for you besides just decreasing your transit costs. So that's all I had today about how to do peering economics, and I am ready for questions.
So if you want to go to the next slide, then there for me, Esther, thanks. All right, so I think in the context of beyond peering and what we're trying to achieve here, I think it's very important for us just to quickly have a look at the scale of Africa and some of the stats around it at a very high level, just to understand what we have to work with in our region. As you can see on the left there, a very interesting thing we did was to take some of the major countries in the world where a lot of internet traffic is generated from, and compile them and overlay them on the African map. And it kind of ends up being very scary to realize, what we have to deal with. And then if you look at the stats on the right, we have 54 countries, we have over 20 cable systems. But I think what's very important to highlight is the fact that we have only currently 46 internet exchange points that service this footprint. It is incredible. I mean, we basically saying, we only have 1 exchange point per country, give or take, and we have to service a continent that has, a very, very large population. So again, going back to what Susan's saying, is internet exchange points truly become the backbone for our access to these subsea cables, to the capacity that we have. and also the content that we need. Thanks, Susan. Oh, sorry, Esther, if you can go to the next one. All right, so we go back and we say, all right, well, we know the continent, we know how big we are and why peering matters. So I think one of the main things that we all know and we all understand is it lowers latency. So it provides us with a direct hop between networks, connects networks, brings them together, and again, in the context of the enterprise, it helps them build out networks that have better performance and better experiences for their users or their customers. We also, I think one of the main drivers behind joining these peering internet exchanges and starting to peer is to reduce cost. I think Susan showed it beautifully, the fact that when we start joining internet exchanges and getting more members onto these internet exchanges in regions, we start relying less and less on our international transit, which we know is a costly expense. Adding to the fact that we reduce latency, have happier customers, happier enterprises using these services, using service providers to do these things, we also, again, provide an ecosystem that ultimately benefits the end user where we want to be. So it's extremely key to choose the right internet exchanges where we have the most members and the most routes. But if we do this in a sort of a conscious fashion, we definitely start relying less and less on our international transit, and that's where we want to be. We want to keep our traffic local as much as humanly possible or within a region. That being said, when we start looking at enterprises as an example, they started moving into cloud for a very specific reason. They want to get the scalability, flexibility we all know. When we start looking at in the space of peering, when we start having people go into carrier neutral data centers, joining internet exchanges, now all of a sudden we have increased capacity. When we're looking at local tails or last miles within country, we're looking at maybe a 5 meg, 10 meg, 20 meg. I mean, some of these capacities in certain countries are extremely expensive. But when we start looking at it in a different view, where we look at internet exchanges and data centers, instantly we have this ability to go and increase our capacity, increase the speed, lower latency. So the story just keeps, adding up and adding to the reason why peering and internet exchanges are so important, even in the enterprise space. And again, finally, when we look at why this matters, it ends up being a direct result or direct value add for our customers, for our users. Lower latency, less let's say reliance on international transits, overall happy customer, and again more business for all of us, and just a much better environment and ecosystem to work in. Thanks, Esther. All right, so now we've looked at why peering matters. Let's look at the value of the internet exchanges. I mean, the first one and the most forefront of mind is bringing networks together. That is something that in internet exchanges and the people working very hard behind the scenes have been extremely good at doing, and that is why it has just grown strength to strength. So it's a neutral environment. It's a platform that's provided for members to join, and as more members join and the experiences improve and the services available, more members join, and it's sort of a knock-on effect. And again, it's such a nice environment if it's done correctly, because again, there is it's neutral. There's no pressure. There's no partiality. So that's a definite value. Now, again, if you contrast that to what traditional IXs have been looking at themselves and saying their value is more in the capacity that they provide, or the amount of content delivery networks or operators or large hyperscalers connected to them. I wanted to try and just highlight that we kind of sometimes missing the point here in where the other value lies with internet exchanges over and above just a conversation around capacity. So I think one of those elements that I've personally experienced over the past few years is what separates a normal internet exchange with a really, really good one is that they act as trusted advisors, not just for the service providers, but for all members. And again, we want to try and get the message out there to get enterprises on board into internet exchanges, to build bigger networks, larger networks, advertise more routes, rely less on international transit. So again, when you have an internet exchange that's inherently involved in your ecosystem, they act as sort of a trusted advisor. They act as a broker to new relationships. Again, one of those things I've personally experienced time and time again is the value of an internet exchange as a broker to new relationships. We've managed to build out enterprise networks using internet exchanges and the knowledge that they have and the people that they know and the members that they have to great effect. And ultimately, as I said, the net result is giving the customers the best experience. And then finally, what we find there is new services. So I think the reliance on, and again, in the context of beyond peering, internet exchanges aren't just a place for networks to peer, but there's also new services that they constantly, bring to the table that service providers and enterprises can kind of jointly work together and actually do things with. So, and I think the one front and center at the moment is the cloud exchange, and I think that has added the most value. Notwithstanding COVID, but even prior to COVID, I feel that services like L2 services available through internet exchanges, but predominantly the concept of a cloud exchange or a cloud on-ramp has been extremely useful as new services are concerned. Thanks, Esther. If you just go to the next slide there. All right, so how do we this is a very high level, and then I'll explain how this diagram sort of contrasts the before and after scenario, bringing all these various elements together. So, I'm taking a look at a couple of our enterprise networks from, let's say, 2016 prior to that. And what I just didn't depict correctly, with more detail, is the two circles indicate a local exchange that we connect to pick up internet or IP transit, and then that goes to a UK internet exchange. So prior to 2016, and this is avoiding the additional work that, again, going to the broker of new relationships conversation I had just now, where our internet exchanges have gone to the content delivery networks, to the large hyperscalers, to where the content is, trying to broker these relationships and bring them locally. Prior to that, we basically had enterprise networks that had to buy, or generally speaking, buy a local loop to a local internet exchange where they can pick up IP transit. And that IP transit, let's say in this case, will go to London, where in most cases, that's where our content was. So you can see a net result is we had access to, some of the content there that I've just put in the bubble there, but at very high latency. And there was no other way. So what we have done on the right-hand side, with the evolution and the real inclusion of internet exchanges, on the continent at least, brokering these relationships, getting the content providers to bring their content into onto the continent, adding the concept of a local cloud exchange. You look at it, what it looks like now, where customers will buy access into a local internet exchange where they have access to a cloud exchange. And at the same time, the content providers are connecting to the same content, exchanges. And you have the flexibility of now going and peering directly, or in the case of Microsoft, for instance, with public peering, or using Microsoft as your peering services as an example. But the list is endless, and the opportunity is there. But you can see the massive reduction in latency is one of the main benefits, plus the capacity. Now we can peer with a content provider at a 1 gig, 10 gig, 100 gig, for instance, where before we were buying IP transit at a per meg cost. So it's a great cost saving on that side, and also just a really good scenario to be in. Okay, next one, thanks. And I think, in summing everything up, and again, with the concept of beyond peering, what is the future value of the African Internet Exchange Point? What are the enterprises that we have discussions with all the time? What are the service providers looking at internet exchanges for that future value? And I think one of the things is to keep driving that conversation with enterprises and large, peering partners and getting more members on board, expansion of local routes. The implementation of more cloud exchanges would be, something that would add more value on the continent. Peering services automation, we see that in some other regions, and we want to bring that into the African exchange and say, do the same thing, automate peering services, making it a lot easier to peer with other providers or service providers or enterprises. SDN services, we're talking about point-to-point connectivity, data center to data center, using the footprint that the internet exchanges have largely built in combination with data centers to greater effect. And finally, providing more live stats and analytics, which again, going back to what Susan's saying, the more you know, the better decisions you can make in terms of strategy. And that's ultimately what we also see as future value in the internet exchange.
Hi, we did have one question, which has now disappeared, but I'll ask it anyway. It was from Sammy, and it was asking, so how many African countries do not yet have an IX, and do we have any plans of getting them on board?
Okay, so off the top of my head, we're probably sitting with about 5 or 6 countries I can think of, very, very easily. Countries like Somalia, for instance, would be a good example. I think one of the biggest issues with why we don't have anything there, for instance, the case of Sudan, it's an embargoed country, so it does make it very difficult to operate there. And people in there, well, let's say consumers or customers, enterprises in there generally just try and find long line services. So I think the plan is, again, we look at the regional hubs and getting the message out from there. So we rely on some of the bigger internet exchanges or bigger names in that region to kind of push that message. But barring the embargo countries, obviously, those are very difficult to operate in. So that's been our experience as well. I mean, we operate in 51 of those countries, so I can tell you it's not always that easy. But yeah, answering that's pretty much what I'd say.
Okay, and then we have another question. This is from, I can't see who it's from. The question is, what is the experience which you share with the countries which does not yet have IXPs, like Niger Republic, people who are still working but don't have the common vision for an IXP?
All right, so that's a really good question. I think we've got 2 ways to answer it. One is from the element of a political aspect. It's sometimes very closed-minded people that are running the regulators and making the decisions. And also at the same time, there is a cost element where the local in-country incumbents are trying to keep as much as they can and try and push as much as it over their expensive IP transits and where they can control. So it's sort of, sometimes it's the case of just being very close and narrow-minded and not understanding the true benefit here. And on the other hand is they're trying to sort of profit as much as possible, but that's sort of very subjective, I guess.
And then we have another question for you. How cloud exchange is done, and he means in terms of the agreements. Is it made regionally or locally?
Well, you would have that done locally with your, I mean, there's 2 elements here. The cloud exchange itself, the organization that hosts the cloud exchange, you would have an agreement set up with them directly. And the agreements with the cloud exchanges that you peer through are also considered sort of regional. So depending on where the location you would sit. So I guess high level, that's the quick answer there.
Okay, and we've got another question. How to get forming a roaming provider like BICS or PCCW as an IX peering member without fights with the former telecom operator?
That is a very difficult question. I mean, we work with these people as well, so I can tell you it's that I don't have an answer for it. Like that's not going to cause any issues. So I'll, you know, it's about probably speaking to the right people, and trying to find one open-minded person within that organization and getting the message across, and then trying to drive it from within, as opposed to trying to drive it like outward from the outside. I guess that's the best way to explain it.
Great, thank you very
much.
much.
Great question.
I think that's all the questions for you, but we do have a question for Susan.
Cool, thank you.
Thanks,
you. Everyone.
Okay, Susan, we have a question for you.
Okay.
It says, in which circumstances, it's about the pros and cons of the root server. In which circumstances would you recommend it or not for someone to use the root servers?
Well, you know, if you are, you know, if you're new to an internet exchange, using the route server has some advantages, because like I said, you only have to, you know, usually an internet exchange will have a primary and a backup route server, and I would recommend pairing with both of them because they do go down from time to time. But if you paired with that, then you would get a lot of routes right away and get, you know, a lot of benefit for moving traffic onto the exchange. And so that kind of gets you up and running very quickly. The other advantage is that it does take a lot of time to to contact all of the individual peers on the exchange and create you know, peering sessions with them. So this, you know, has a big advantage in terms of speed. The disadvantage for a route server, though, is, you know, like I pointed out in my presentation, you don't have any control over, you know, who's peering with you over it. And you may not want to listen to some routes from the route, there's some peers on the route server, because maybe you're peering with them other places, or, you know, you don't want to listen to routes there. You want to prefer other paths for latency purposes. Lots of reasons why you might not want to. And if you are, you know, skilled at BGP, you can always filter those paths out of the announcements you listen to from the route server, or you can, not you cannot listen to the route server at all. So, you know, it just kind of depends. But that's an example of when maybe peering with the route server wouldn't be a good idea. The other thing I also mentioned is that you a lot of times will get more routes from a peer peering with over a PNI than you will, or not a PNI, but just a private peering session over the exchange, than you will from the route server, because like Hurricane for Electric, for example, we advertise about half of the routes that we advertise to peers to the route server. So if you peer with us directly, you get more routes. So those are all reasons why you might want to do it. And it is kind of an individual thing. You know, it's where you kind of have to take a look at the situation and evaluate it for your own personal experience and what makes the most sense for your network.
Great. Thank you very much, Susan.
All right. So hi, everybody. My name is Mark Daley. I'm the Director of Digital Strategy and Biz Dev for a company called Epsilon. We provide connectivity solutions to the world's communication and cloud ecosystems. And personally, I focus on looking at new trends and technologies, anything that's sort of impacting the world of communications. And today I'm going to talk really about future trending in terms of programmable telecoms. So hopefully I'm presenting a fairly interesting and new topic. Really what I'm going to talk about is the evolution of telecoms as a resource, and how exposing telecoms functions in a programmable manner is changing many aspects of our business and industry, and it's even now starting to impact the internet exchange world. So today I'll talk about how we present these telecoms functions as kind of like a tool set, and not just for telecoms folks, but other people and industries via tools like portals for use by our end customers and others, APIs to other telcos using capabilities like SDN and SDN interfaces, APIs.
Sorry
Yep.
to interrupt, we can't see your slides.
Oh, really?
And then they vanished. If you could start them again, that'd be great.
Okay, that's kind of weird. Let's try it again. So let me know. You can see them again?
Now we can see them.
I can see. Yep, that's it.
Yep.
Now we can see them. Perfect. Yeah,
Okay.
all good.
Apologies, I'll just stay on this slide. So what I'm really talking about on this slide is around the trend for programmable telecoms to feed into functions like internet exchanges, telecoms functions that are presented via portals, APIs, etc. And then what I'm going to do as well is focus on the impact to the business world about what we're doing within this programmable telecoms world. So hopefully all that interesting and kind of very new topic for most of us. So programmable telecoms isn't a new concept. Actually, it really started with voice services and something called IN products or intelligent networks back in the 90s. And telcos started discussing the concept of presenting voice functions in particular as a programmable element in other applications. And sorry, this is kind of, here we go. I'm on the wrong slide here. So really what happened was that we had a technology, I'm just trying to get to the right slide. I do apologize for the hiccups. So we had a technology that was first created called Parlay, and this was the first kind of major step in how we presented functions as programmable elements to telecoms developers. So the focus was telecoms developers. This Parlay thing now is actually called One API. It's the current GSMA standard for telecom third-party APIs, actually, so it still exists. We then evolved to full architectures such as Jane, if anybody's heard of that, and that means Java APIs for integrated networks. So these are all in the sort of the 90s and the year 2000s. And then to provide additional programmable functions such as messaging, companies started being formed. There was a company on the west coast of the USA called IntelliPeer. And IntelliPeer actually still exists, by the way. They started developing kind of programmable single elements like messaging. And these type of programmable single elements started getting more and more of them. And eventually, this kind of capability and this set of capabilities led to the success of companies like Twilio. And I'll talk about Twilio in a minute. Data networking sort of began evolving its programmability over this period as well, mostly focused on sort of open standards, a lot of manufacturer involvement as well. But the manufacturers started sort of catching up and started leading the way as well. And this drove some particular issues in terms of programmable telecoms. I'll talk about a bit later too. So what we are now, we're at a point where we've really have an evolved set of APIs for many different functions. And on the next slide, what you'll see is that basically there's kind of 7 sets of APIs that telecoms people should recognize or recognize at least some of those APIs. So these have become or emerged in our telco space as really kind of, I guess you could loosely call them telco standards. So these are industry standards being developed by industry bodies like the Metro Ethernet Forum and TM Forum, and they have packaged sets of APIs. Independent telcos, Epsilon, for instance, we developed our own APIs. A number of other telcos have as well. Vendors, they've developed their own APIs for their own software stacks. IaaS or EaaS, the cloud guys for layer 2, layer 3 interfaces into their cloud stacks. And, you know, they have literally thousands of functions now. AWS, if you go to their events and that, it's mind-blowing. PaaS and SaaS companies too. So they've developed their own application stack, programmable interfaces. And then finally, and maybe even more interesting for this community, is that community APIs where developers and engineers specifically from telecoms have created really interesting tool sets. Say, there's a really interesting one to Google called Napalm, which is about network connectivity over lots of different network elements. Really interesting topics. And I'm sure there's many others that the audience is familiar with as well. So we now have these kind of sets and standards of APIs that are very, very applicable for us at least in the telco space. So then the type and complexity of service functions being presented through programmable telecoms is continuing to evolve as well. And this is also driving change in what we've come to know as SDN, or software-defined networking. So as SDN is maturing, the functions presented as controllable and programmable capabilities, they're increasing as well. And you can see on this graph on the right-hand side, the stack that you get within the SDN environment is just keeps growing and growing. Micro functions such as policy control, identity management, security elements, they're all now being presented as mini resources even within the SDN environment. And so even the SDN stack is continuing to evolve. So then if we look at, okay, I'm talking about programmable stuff all the time. So if you think about this, programmable telecoms functions are enabling the monetization of telecom services in kind of different ways. And we're not always taking advantage of that as telecom service providers. Communications platform providers, or CPaaS, as a sort of communications platform as a service companies, they present telecoms as a resource to developers, as tool sets for new and innovative ways to enhance others' applications, like their customers' applications. A good example would be a calling function within a taxi app, so the taxi driver can find where you are. So it's the CPaaS guys who have created and monetized these new types of approach to enabling business applications. And they've been really successful in this monetizing capability. And they're usually doing it with services that we provide, and they're monetizing functions that we never were able to in the past. You can see on the slide here, there's like a couple of revenue estimates. They're kind of wildly different, but they're both really massive. But here's a really interesting example. So this company, Twilio, if you've never heard of them, give them a Google search later. But their revenues are now at about $1.134 billion US dollars. That's billion US dollars. And what they do is they sell our services. They are not a telecoms company as such. They present telecoms functions as a resource to the developer community to then utilize them in other functions. So these companies have done very well through programmable telecoms to monetize new services, probably far better than we have, unfortunately. So interestingly enough, I'm very old. And as telcos, we kind of had our chance at a lot of this and we missed it. Graphical and even programmable service functions have been available to us for a long time. But we've tended to keep it a secret, and we just use it, or used to use it, for ourselves. So for our own engineers, our own kind of service creation. The example in this slide is a graphical call flow engine from an IN platform just after the year 2000. So on the left-hand side, this is kind of what some of us telcos could use, but we always used it internally, and it's for a voice service in this example. On the right-hand side, this is from Twilio's Flex offering that they launched in 2018. So about 17, 18 years after we already had this. And they allow others to create their own call flows, basically just present it out as a graphical interface. And you can go and create your own call flow as a developer or even as an admin person. So the genius of companies like Twilio has been to expose these functions to the development community, who have then sort of created interesting and innovative uses for their own companies and customers. And this is the continuing trend which continues to impact and drive us today. So telecoms as a resource and its solution components have really already become tool sets for others. And where I'm leading now is, if we start to talk about sort of as an industry, we are working on how to take the next step to support functions such as digital product threading. That's a big one for us as an industry now, is threading products together in a programmable way to deliver solutions. creating those service tools to enable that, and building ever more sort of interworking and interconnected business orientated ecosystems. So as an example, systems integrators are out there now looking for tool sets that enable them to build sort of bigger and better and easier to deploy end-to-end integrated service solutions for their enterprise customers. And using these tool sets to interwork not just functions and services, but also the business ecosystems themselves becomes very interesting for both the SI and ultimately for their customers, the systems integrators. So I've got an interesting example here. So many industries are seeing digital and online capabilities changing, if not disrupting, their own traditional segments. Banking's a great example where certain sub-segments, such as the younger consumer demographic or millennials, are being targeted with agile, on-the-move solutions with more visibility and usability than traditional banks. This company here, Monzo, they're a UK company. They don't have any high street branches. They're fully online and app enabled. They're wildly successful. In the UK now, they're the most recommended bank. And as we know, banking in Africa has had a digital lead for many years. So we see a lot of digital change in this particular segment as an example. And that's being led by the ability for people like telecoms companies and other functions through programmable networking and programmable functions. All this change has already impacted us in the telco world. We've already, for incumbent telcos, had a lot of non-traditional challenges, particularly to market segments like the SME for services like voice and contact solutions, and it's now moving into the data world, and we see non-traditional challenges even in global telecoms. So programmability in telecoms is good, but it's also a challenge for some of us telcos that have been around a little longer than a couple of years. So if you were thinking about, okay, what does all this digitization kind of mean to my company? And if I wanted to present my services in a more kind of e-commerce or digital model, what I've done is created kind of a list of the 6 key functions that if you were going to present, say, a portal, this is where you would start, or I think from my perspective, I would recommend where you start. So the first step is thinking about visibility. How do you make your products visible? And it's like me wanting to buy a new shirt. So I go online to like Amazon and I'm looking for shirts. So presenting that category. And then once I've found it, I need to configure the shirt. So I want a white shirt, I want size large. For us in terms of services, that's like I want a 1 gig service and I want it for 12 months from here to here. So once we configure that service, we get a price. So being able to present that price, I like the price, I can order it. So online ordering has become really, really big, certainly in some sectors of the marketplace right now. So I'm placing the order. And this is where we kind of transition into something called orchestration, or part of the SDN function is I now have the spec through the configuration. I can push that down into the network layer and spin that network up through SDN or orchestration. We call it deployability. And then the final one is, okay, now I have a service running. I can see that the value of the service, I can see it's green, everything's great or not. And I can manage it. If I can see, like visibility is control. If I can see that service and how it's behaving, I can do something about it if it's not behaving in the manner that I want it to behave. So where's all this kind of leading to, and particularly relating to the IX? So first off, sort of in analyzing where this next generation of network is heading with all this stuff going on, I just want you to think about this. It's all about the app. It's all about the business application or the consumer application now. That's exactly the thing that ICT people focus on. So the massive rise in this hybrid cloud-enabled applications and and the creation of remote data and apps that are all over the place means there's more and more need to provide good mission critical connectivity and address that interworking element. So this is very, very good for telecoms companies. ICT people face, more and more challenges to improve the application accessibility, the perceived performance of the application through networking. And they have a real challenge in integrating not just the applications, but also the networks that enable the applications and present a user experience and a computer to or system to system experience as well. So as applications start to be classified as, say, mission critical, so too is the connectivity they depend on. So think of connectivity as mission and non-mission critical connectivity. And that makes it a lot easier to start to talk to ICT people about what it is, the problems they're trying to solve. So the next step is presenting different internet and connectivity options, I think, as part of a manageable enterprise network, focusing or enabling access to and from different business applications using the network tools that are available. And of course, the internet is a really big part of that. So the coming together of the need to access more and more varied applications, more efficiencies and better performance means that the internet exchange is going to directly become part of the enterprise networking. And we're seeing trends for that to happen right now in Western Europe. So it's already happened in a couple of the exchanges, and you can see some of the logos sitting behind me where they're experiencing this right now. So we all know that what enterprise needs are from a comms perspective. You probably hear about it all the time. I need this, I need this. But interestingly, it's my belief that the ability for internet exchanges to help with these drivers is definitely there. From an IX perspective, there are probably 3 elements that will become a focus for the future in order to support enterprises. And that is to support the continued verticalization of the IX community. So more and more layers of types of companies to enable IX functions to be programmable and to enable the ability of cause and effect and other sort of business rule functions to be built and deployed for automation. So it's a real kind of challenge to the IXs, but I think they can deliver it. And then in the future, it's my belief that through programmability and AI, applications will start to be able to drive the network as well. We already have the pieces in place. They're only now starting to be presented as interworking functions at the different network levels, but SD-WAN is a very good example. So it's a good example of how our application is becoming visible, or applications, and they can have their own policies and end-to-end views with just a few keystrokes. And then if that data is delivered and presented down and pushed down into the physical network, then it could be that the application says, hey, I'm the CRM system, I'm mission critical, I'm going to take preference over Netflix as an example. I don't want to pick on Netflix, but and so the application is telling the network that it needs more bandwidth, the network needs to expand, etc. And the pieces are just about there for all this to happen all the way through the layers. Now, of course, we've kind of had a lot of these functions available before, but remember, the magic is exposing it to others, whether it's other network layers or other technologies or other companies. So finally, I think the summary needs and drivers for the evolution within the IX and its community include improving the ecosystem integration, developing multifunction and multi-purpose APIs, probably enabling more visual control of and federation of services, driving automation of the peering function itself, definitely, giving external access to companies like Epsilon, perhaps, so that we can control and enable things like remote peering and use and integrate our SDN, present more and more statistical and decision-making data. LINX can sort of give more access to defined sets of network fabrics, communities, so presenting communities, perhaps creating sort of different commercial models or maybe not, and thinking up interesting functions as a service. So wrapping up, I see the internet exchange is becoming more than a community exchange point, but also a resource for managing how sort of all companies can be efficiently configured and enabled to function better. So that's it. So I hope you've enjoyed the presentation, and I thank you for your attention. And I'm not too sure if there's any time left for questions, but there you go.
Thank you very much, Mark. We've got one question for you. And that question is, what would the perfect IXP legal status in line with service evolution can we deploy at an IXP, association or commercial?
I think it's a combination of both, actually. So from my perspective, there is an ability in the future to monetize enterprise type enablement within the environment, but I think both. I think as an association, we already see right now that banks are keen to join up with what you might call commercial IXs. And so that seems very acceptable to the banks. The only question that sort of large enterprises might have is the package of an SLA. I think the type of entity that's managing the IXP as a business isn't as big a consideration as the end-to-end sort of SLA, and those big guys are very traditionally minded when it comes to service levels and guarantees in particular. From a commercial perspective, managing IXPs, I'm seeing right now that, in my opinion at least, there's very little difference in terms of success in addressing these newer segments between what I would call sort of more membership orientated IXs like LINX and more commercial orientated IXs or for-profit type IXs that are out there as well. I think they both have equal success. I think it's going to be more about the service bundle and the guarantees. I hope that answers your question.
So my presentation fits very well in what you've seen over the last couple of presentations. So I'm presenting a little bit how internet exchanges have evolved over really over the last 20 years and where we see them going in the future and what we see the demand is. I obviously use LINX as an example, but you will see very similar developments at pretty much all of the internet exchanges. Just a couple of words about LINX for those who don't know us as much. So we have been around for 26 years now. So we have been doing this for quite a while. I've been at LINX for the last 10 years. We are fully membership owned. So we're not a commercial, so we're not for profit, we're mutual. And as a consequence, also neutral. It's one fee, every member has one vote. And we've also been known for leading in the way in the engineering solutions that we provide. Just as an example, 2 years ago, we made a decision to go for a disaggregated model for one of our peering lands in London, where we use the hardware, kind of white box switches and the overlying software from a different supplier. These are just a couple of numbers to give you a bit of an idea of the size. We're actually running multiple exchanges, which are all run independently. They are not interconnected. So we have our two main exchanges in London, which are by far the largest. And we run 3 regional exchanges in the UK, Manchester, Scotland, and Wales. And we run an exchange in Northern Virginia in the USA. And last but certainly not least, together with STC, we are operating JEDIX, which is located in Jeddah in Saudi Arabia. The aggregated traffic level of the exchanges combined is above 5 terabit per second. So it's a sizable exchange. So the evolution, well, what have we seen in regards to who's using exchanges and what type of traffic do we see across exchanges? In the early days, and that's how a lot of the exchanges got established at the time, it was simply a couple of service providers who all knew they want to improve how they're interconnected to each other, and wanted to simplify the way and have a neutral place where they can interconnect all of their networks. The focus were really everything what at the time we called tier 2 networks. The tier 1 networks, as they wouldn't really peer, they were except between themselves, they probably wouldn't join, but all of the tier networks and below would join, and the main goal was really cost savings, efficiency of cross connects, and also having a neutral place where they can do all of that. What we then saw was the growing amount of especially video-based traffic on the internet, the upcoming of YouTube and streaming services, was the arrival of CDNs. So where in the early days it was really purely you have your service providers, and most of them had all a combination of content that they host or eyeballs which are directly connected where they provide the connectivity to. That all changed with the CDN, where we got that very clear split in between what are content networks versus eyeball networks on the internet, and that clearly was one of the main reasons why we saw during a long period of time pretty massive increases of traffic on a regular basis as the internet evolved and the amount of traffic evolved across the internet. The next step then was CDNs realized they want to move even closer to the edge, closer to the end user. They started to implement caching servers, which very often they hosted directly in the broadband providers' networks, so in the eyeball networks, much closer to the end user, and that shifted a lot of the high volume traffic. To a certain degree, shifted it away from exchanges, which doesn't mean really that traffic at the exchange has dropped, but maybe the growth did slow a little bit as a lot of the traffic doesn't really pass as the caching server, with their main goal is to keep it close to the edge and reduce the amount of traffic having to be carried around. That's really where we were. What is changing now, and what we see as the next evolution, and it got mentioned in the previous two presentations, both from Mark and from Nico, is that there's new market segments which have discovered over the last couple of years, and we clearly see an increase there, who see a benefit of internet exchanges, and that's to a large degree corporate enterprise type customers, so really more the end users who want to improve their connectivity. They rely much more on their day-to-day business on having good, reliable connectivity for their network, for their users, for their staff. A lot of what at the time your IT department had a couple of servers in a cupboard, that has all moved away. They either use data centers or even have their applications and services hosted in one of the cloud networks. They've also realized that if they just rely on a single internet access provider, they kind of all of their balls are in one, all of their eggs are in one basket. And they are fully reliable on that and don't have any control, any influence themselves over how they reach certain parts of the internet. And they want to have more control and better visibility of how the traffic flows and how the traffic gets to their destination or gets back to them. So all of these things together mean that a lot of networks, a lot of companies that before probably weren't too worried about it, are now looking at what options are out there. The other thing that we've seen, and we've seen that in the past, and we see it again, is the demand to having kind of closed user groups, so dedicated layer 2 environments that get used for specific use cases, either specific applications or specific setups between a smaller set of companies who want to exchange data direct between them without using a public peering point or public infrastructure to do that. a big and important part of that is, of course, cloud connectivity, and even though there's certainly no lack in options of how you can any company can reach or improve their connectivity to different cloud providers, and using all different technologies, starting from very basic non-encrypted tunnels over IPsec-based VPNs, or depending on the importance for them and the amount of traffic and how much they rely on the availability, to layer 2 circuits. And we clearly see a lot of demand from existing members that are connected to LINX, but also demand from companies who approach us and are interested in joining an internet exchange, in asking if it is something that an exchange can offer, kind of broker that connectivity directly to the cloud providers, having local on-ramps directly connected to the fabric so that they can use their existing ports, save on cross connects, and get a direct layer 2 connection to cloud providers. And there's a number of things that are working there. And again, it's the factor of having the internet exchange as a well-known, trusted entity sitting there, providing that functionality is clearly something that the market is looking for, and that a lot of exchanges start to offer now, either doing it themselves directly or working with partners to provide that connectivity. Couldn't do a presentation without asking this question: is COVID-19 impacting any of this? The simple answer is yes, of course it does. So what is changing? There's clearly there's an increased amount of traffic generated by people working from home, not sitting in an office. And even though we all expect to go back to offices, we also think that the new normal is going to be that a much larger percentage of people are probably going to continue to work from home. And that changes the traffic profile and changes the way companies look at their connectivity. There is something that we call the long tail quite often. The long tail is the large set of very small networks that provide connectivity either for certain areas in a country, or for specific use cases, where even the large content networks see now a need again to improve their connectivity to reach all of those networks, whereas building cache servers works obviously for static content, for video delivery. The cache networks don't really help for a lot of the services that need real-time interaction, i.e. a lot of the chat functions or even Zoom calls that get presented. A caching server doesn't help them. So even a lot of the content networks are looking again in increasing their presence and how they can reach as many of the networks out there as possible. So again, importance. And we talked about this. The requirement to have reliable connectivity is clearly increasing even faster in the current situation, and it further drives the adoption of cloud services for a whole number of reasons and a whole number of criteria. The next part, clearly an important part for internet exchanges, and we know that a lot of them are looking into improving on this. And you saw the presentation from Mark. It's the drive for automation. It's clearly the demand, both from our members. Initially, the demand came mainly from partners that we work with, who sell connectivity to connect to LINX, but we also see it directly from members, to have a programmatic way of ordering services, making changes to their services, and those can be very basic things like changing a MAC address, or upgrading your service, the bandwidth on your service, but also going further for members, getting them direct access to statistics, metrics that the exchange has for the member services, making those available through an API to both members and partners is clearly a lot of demand, and similar to LINX, who are working on those things, a lot of exchanges are evolving into that direction. For us, the automation part, whenever we look at developing a new product, the automation part is from the beginning is an important factor of any new product that we develop, and making sure it can be used in a programmatic way for everybody who wants to use it. And there's clearly an industry-wide effort and a certain drive to standards, and we're going to see a little bit in the demo after this session. One of the use cases. So IXAPI is a project that's a collaboration between the three providers that you see in the background, so LINX, MSX, and DKIX, to create a common API that can be used for all of our exchanges, and it's developed in a completely open and transparent way, and clearly the goal and the interest is there for the internet exchanges to adopt the same API to help move us towards a standard way of making our services and our data available through APIs. As a summary, and I tried to keep it a little bit short so we can catch up a little bit on time. So the summary, really, we all know it, and we have seen it in all of the previous presentations. There's clearly an increasing demand to have diversity in the different needs that enterprises, service providers, and everybody has for their connectivity, and providing a common place and a trusted platforms. Clearly, IXPs, internet exchanges, are clearly a good starting point to offer all kinds of connectivity and interconnection methods to existing networks and new companies who are interested in improving their connectivity. Doing that in a simplified, ideally automated, and cost-efficient way is clearly where the focus is. And most of the exchanges now cover not only peering, private VLANs, closed user group, cloud connectivity. They're all elements that we see all of the exchanges evolving in over the coming years. And that pretty much covers everything I have.
Hopefully we've got the share. So I'm just going to do an introduction first, really, of the actual kind of case that we're talking about. And so really what this function is talking about is enabling remote peering in an automated fashion. So the establishment of a VLAN from a third-party network, such as Epsilon's, all the way through to the internet exchange. And at the same time, what this process is doing is utilizing a common gateway or reseller port into LINX in this case, establishing the fact that the peering or remote peering customer has a name, they have an AS, they want to establish a relationship within the internet exchange, and then have the physical layer 2 connection set up so that then the layer 3 and the BGP and everything can be configured. So it's really, okay, I'm over here, I want to connect to the internet exchange that's over there. I don't have a POP there, unfortunately, but LINX and other IXs through remote peering allow companies to still participate and peer in that internet exchange even without physical equipment. So the premise of the demo is that we have a port established already in this purple bubble in the Epsilon network. The customer or the member already has a port there. So now we're going to establish a service, and just showing the type in. So while I'm kind of getting this logged in, so to speak, it's a graphical demo. Basically, let's start again. Let's do that. So basically, this is a portal of an SDN environment. So this is the Epsilon one. There are a number of SDN functions out there now. So we've landed into the SDN environment. Our layer 2 connectivity is called a Cloud LX. So I'm just jumping into the environment that's going to allow the establishment of the connection. So I'm going to connect on a connection point. SDNs now generally show 3 types of connectivity that are driving programmable connectivity. Clouds, Mike in his great presentation already spoke about clouds as a very interesting point for the IXs. That they are driving billions of dollars of connectivity in the world right now. Internet exchanges, of course, and then just other networks, other data centers. But in this case, we're going to connect to LINX. So we're going to click on, I want to connect to an internet exchange, obviously LINX. I'm not going to worry about an area. I can see LINX down here as well. So I'll just click on add a service to LINX. LINX is in the US as well, but we're going to connect to LINX in London. And so just go through that waterfall selection. We're going to connect from in Africa. So we'll choose Cape Town in a Terraco environment. And so you can see here, already have a port allocated to connect into LINX. We're going to choose that, but you can also see there's other ports there. And a lot of SDNs will also show that that port's in use. This one here is running at 5%, but we're going to connect using the LINX port that we pre-allocated, take a network protection service for a year. We're going to select just 50 meg. And then we can see a price. Remember my 6 points. We're going through that 6-point process right now. So I'm going to put a service name in, just call it LINX service name, choose a VLAN. I can see the available VLANs. I'm going to choose 3 actually. Put AS number for the demo. I'll put Epsilon's AS number in and Epsilon AS set as well. Obviously put a MAC address in. So what we're doing is essentially filling out the LINX application form, but it's now embedded into a portal. So we're not inventing any real new data here. We're just really digitizing the LINX form. And so we have all the normal contacts you would expect to fill out on your LINX form. So I won't go, that's already filled. And so I'm at that confirmation stage where, okay, I definitely make sure that this is the service I want. It's LINX in London to Cape Town. You can see all the details there. Like most portals, I have to agree to the T's and C's, which can be clicked on and read, and I'm going to buy that service. So now essentially what's happening is we're buying that service. This configuration process is now the call out where the API has been invoked. So it's the LINX version of the IX API has been invoked, and we're sending that data through to LINX. That provisioning process is occurring. So we're orchestrating the service within the network itself from Epsilon's perspective. We need to wait for confirmation from LINX. So from the A end, the service has now been set up, and usually it takes like literally like this, a few seconds. You know, at worst case, if you are configuring lots and lots of different endpoints, maybe a couple of minutes. That's the SDN. But now you can see that the service has been established, but it's still down because we haven't had the confirmation and response yet from the LINX end. So if we're looking at the API, so don't forget, this is an API interface that was designed by the internet exchanges, and LINX being a huge participant in the design. So we've basically utilized the different API data, pushed that out, captured it, pushed it out, and that's been accepted by LINX. So I won't go through the context of the API, but the IX API website has all the information. So we're sending customer information, et cetera, in that API. And so that now heads over to Mike, and then it's Mike and his team who actually have to go through and check all this information. And I'll hand over to you, Mike.
Yeah, so what you see here is basically our internal CRM system, and you see here the entry for the customer that got created. Important to see here, since it's a new member, On the top left, you see the membership status is currently as applied. As we are a membership organization, the API won't have there's a manual process involved to prove that membership. Through the API, we also got the details of the different accounts and contacts which got created for this one. So if we go to the next one, we'll see those contacts being created. So this is the first one, which was the legal and the billing contact, which got created here. And then the next one will be the technical contact, and which will be the NOC contact and the implementation contact created for that. And last but not least, there is the entrance for the service that got created as well. And again, in this stage, as this is a completely new service, you can see at the bottom of that page that currently the service is in a reserved status, but all the details are there. A port has been allocated. We see the MAC address that got passed to us through the API call. In this case, this would now get picked up by one of our NOC engineers, provisioning engineers, who would validate it and then push it out through our automation platform to the network. If we would use an example of a change to an existing service, there would probably be no human intervention. The API call would come in and it would straight away, if all the information is present, it would straight away go from our system to our automation platform and pushed out to the network, and the change is applied. But this shows the data as it arrived at our end. Head back to Mark.
Cool. And thanks, Mike. So then once Mike's team actually validate and confirm all of that, the pushback is in terms of status that the services end-to-end goes live. And then within the SDM platform or the portal here, you can now see the full end-to-end service health. Hopefully it's always green, but the service is up and running. Start pumping data over that, sending traffic, and like any sort of normal portal and service statistical capability, you can now see the traffic and the health and how it's performing from end to end, from the network port all the way through to the IX port, peering port. So that's basically it. What it does is just really change the user experience from a configuration perspective. Saves a lot of time and effort with companies like Epsilon, and you can imagine that as Mike and his team build more and more programmable functions over that API, it will also expose more and more features, and he mentioned a lot of those features they're thinking about already in the presentation he just did. So thank you.
Thank you. Thanks to all our presenters. Thanks to our sponsors today, NAP Africa, Flex Optics, D6, AMSIX, Facebook, and the team at LINX. We hope you found the presentations and topics interesting today. Just a couple of other events coming up. LINX are actually hosting a Women Tech Connect event with Work Online Communications. It's a great initiative which was launched a couple of years ago, and it's really valuable networking and interaction, discussing and promoting positive change for women working in the ICT workplace. So I'll drop the links to the information in the chat function about that. The topics we'll be addressing is the working from home or living at work. Which camp would you put yourself in? And also lipstick and leadership. So it's some really interesting topics. I'll put the links to register in the chat. The next event in the virtual peering series for the AFPIF series here is IXP traffic behaviour during the pandemic in Africa. And this is taking place on the 3rd of November. Again, I'll drop the link in the chat function to lead you to have a look at those as well. So that's it from me. Thank you ever so much. Thanks to the event organisers for giving LINX the opportunity to host and moderate this session. We hope you've enjoyed the topics, and I'll hand back now to the event team for the peering personal.
Now we'll go over to the peering personal sessions, and as I share my the slides for the peering personals. Okay, so the first person on screen is I think Rupert. Do you have Rupert in the room? I don't see Rupert in the room for digital reality. If you could you raise your hand up? In the meantime, we'll go to the next person, CCOM. I see Noah. So Noah, please, oops, go ahead, Noah.
Hello?
We can hear you.
All right. Yeah, this is Noah Maina. I'm the peering coordinator for CCOM. CCOM is basically a network service provider based out of multiple countries in Africa. And I'll just quickly go through our peering personals. So our AS number is 37100, and we peer in NAP Africa at all the 3 locations. We also peer at the INX in South Africa. So that is Jinx, Dinks, and Sinks, and then AM6 in Amsterdam, and IXPs in Frankfurt, DECIX in Frankfurt and Marseille. We peer at France IX in Marseille, IXP in Nairobi, LINX in London, both Slough and Telehouse, and obviously at PIX in Tanzania and the Uganda exchange point. We have also a peering point in Rwanda, which is currently not active, but we hope that it will be active soon. We have a selective peering policy, and you can contact us at peering@ccom.com in case you need to basically have a peering session going on with us. Thank you so much.
Thank you, Noah. Next is KIXP.
Hello, Peter Gitau here. Of TESPOC, managing Kenya Internet Exchange Point. TESPOC is a member of managing the exchange point. We are located in Nairobi and Mombasa. 2 locations in Nairobi, African and Mombasa, also iColor and BA1. We have an open peering policy, can be reached at the email address. Thank you.
Thank you, Peter. Next is T6.
Hello, Michuki. Can you hear me?
Yes, we can. Please proceed.
Oh, perfect. Well, first of all, I would like to congratulate everyone who was on the previous sessions. All the moderators did a wonderful job. First thing first. I will go through the peering personals from DECIX. I am Darren Costa, and I look over the African region. So DECIX, it all started 25 years back in Frankfurt with the AS 6695. And then we rapidly have expanded our reach into different continents and multiple locations, such as Madrid with AS 48793 and Marseille 20717, and one of our newest exchange points on the mainly for the West Coast customers that are getting connected recently is Lisbon with AS 43729. So actually those exchanges listed here are the ones where we are seeing more VLANs coming from our customers, members out of Africa. With regards to locations, as I've mentioned, we have moved very rapidly in the expansion process. So I will just mention a couple of names like Chennai, Dallas, Delhi, Istanbul, Kolkata, Lisbon, Madrid, Marseille, New York, Munich, Palermo, and others. Stay tuned because we might be announcing new locations in the near future, maybe close by your region of activities. Our general policy as an IXP, it's open. And if you're not connected to D6 yet, feel free to drop us an email to sales@dkix.net. And we also have multiple peering DB records. So feel free to have a look into that. Thank you.
Thank you, Darwin. Next is John Baptiste.
Hello, everybody. I'm Jean-Baptiste Milogo from BFX in Burkina Faso. Our S number is 37716. And you can peer with us in Ouagadougou, and we just launched a new pop in Bobo Dioulasso in West region. Our policy is open, and you are welcome if you want to develop your business in Burkina Faso or in the east of Africa. If you want to contact us, it's peering@bfx.bf. Thank you.
Thank you, JB. Finally, we have someone from Morocco. Please raise your hand so that I can see who you are. Should be Sami. Is it you, Sami? Okay. So I think we don't have anyone for Sami, and let's move on to the next one. Andy from Asteroid.
Hello, can you hear me? Yes, good.
Yes.
Hi everyone, that was great content today. I really enjoyed it, thank you. My name's Andy Davidson. I look after technology for an internet exchange point operator called Asteroid. We actually operate a number of exchange points around the world, some under our brand and some with our partner brands, or some on behalf of our partner organizations. We operate an exchange point of our own in Mombasa, in Kenya, in the region, which is why I'm showcasing this exchange point today. We're a low-cost exchange point based inside the ICOLO facility in Mombasa. The exchange point is open to everybody who has an ASN. If you'd like to connect, then just email peering@asteroidhq.com. Somebody will be in touch straight away. And for any networks that are new to peering, we always love to provide any amount of assistance with your setup and troubleshooting at the start. Would always give you plenty of help if we can. So would love to have you on board. There's our traffic graph showing the last month. It's growing nicely. It will grow even better if I could encourage some of you to join. So thank you for listening, and speak to you all soon. Thank you.
Thank you, Andy. Next is NAP Africa. I think we have Yolandi. And you're good to go, Yolandi.
Is it on? I think so. There we go. Hi, everyone. I'm Yolandi. I am from NAP Africa in South Africa. Our AS is 37195. We have 3 locations, namely Johannesburg, Cape Town, and Durban. We have interesting peaks as well. In Joburg, we are reaching a 1.2 terabit peak. Cape Town, we are peaking at 248 gigs, and Durban at 15.4 gigs. Memberships, we have 460 unique ASNs, and always welcome new ASNs to join. We offer 1 gig, 10 gig, 100 gig ports. Membership is free of charge. So as you can see, we do not charge for ports, membership, or cross connects. Our peering policy, we support both multilateral and bilateral peering. We also have RPKI implemented, and we are Manos compliant. If you would like to get in touch with us, please contact us at nap@terraco.co.za. And yeah, that's us. Thank you, guys.
Thank you, Yolandi. And that brings us to the end of the peering personals for today. So thank you very much to everyone who participated. And I do apologize that we've gone slightly over time, but I believe that the content has been quite helpful. For those who registered and had actually selected the option that you like to be introduced to other participants through the networking feature, we will be sharing the contacts of all the other people who consented to the information being shared after this event. So please look out for that email. We also do request you to please provide us any feedback that you may have through the feedback survey form that will be sent to you with the email that comes after the event. So that should be coming shortly. And we look forward for your input on how we could improve this, the next peering sessions. So with that, I'd like to thank everyone for their time and for staying on. I see we've stayed on well longer than we had anticipated, but I think that's a really, really useful session we had today. Thank you very much, and do keep in touch, and see you online and at the next event. Thank you very much.